That information is not available.
Instructions are not needed if commands are succinct.
You know what they say. No good deed goes unpunished.
My interpretation of the data leaves little room for error.
I am checking. Kindly wait. I have the information you require.
I must assume that your request is a frivolous one. The art of leadership is delegation.
How do you do? It's me again, all over again. Hold on a second. Right. So I was gonna go live stream, so it's late, so I'm just gonna do until I get tired. So basically I just need a weatherproof box enclosure for this thing, this PCB. So let's get on with it. So we've got various enclosures for it, as these ones here, designed to go on a DIN rail inside an enclosure, inside a building probably, or wherever, in a house, in a building, in a factory. But what I haven't got is something to go outside. Something to go outside that's waterproof. Obviously these have got holes in them. The closest thing I got was this one here. This is designed to go against a door frame with YT2 trunking. That's what that was designed to do. Yeah, with a built-in power supply with that one, and the board is there. But what we want is a fully enclosed one. So to that end, we'll start afresh, I think. So to start afresh, I need a copy of the PCB, because this gives me all the fixings and everything. In fact, I'll tell you what we'll do. We'll just grab that. Is that part of it? Do we grab that one, or do we grab something? I'll tell you what, we'll grab that one. Yeah, that's more like... And it's got a... Yeah, everything's in there, I think. So I'm going to copy that. Got to set up a new... Got to go to a new file. I'll paste it in place. Oh, paste it. There it is. Zoom in. Right, okay. So I need to give this a file name before we start. So I'm going to save as... Oh, hang on. It's still going to be 3D printed models. Is that the one? No. I forgot where I put it now. Oh, that's it, yeah. So we'll keep on the same theme, but we'll 3D enclosure weatherproof. Weatherproof is not the same as waterproof. Or IP so and so. So I need to set a few things here. So the defaults are no good for design stuff. The default Right, that'll do. So we'll stick the corner. Oh, it's going to be something different in a minute. Well, we'll not take that apart. We'll leave it where it is. Get rid of these axes, right? So what we want, a weatherproof one of these. So we'll take the lid off a minute. Have we got a lid? What have we got? Oh, top. Yeah, got a top. So there's your PCB. And there's our non-weatherproof enclosure. The PCB, everything is set out so we can hide the PCB. So we've got all the holes ready for brass inserts. Now, I've got some experience in what happens with things bolted to things in the weather, because that's basically my day job. I always get water in ingress in proprietary stuff that you buy. So I've seen a few things that they do to avoid this. Now, there is no avoiding getting water into it. It might sound crazy, but you're going to get water into it. So you've got to design it to be able to cope with passing water through. And what you don't want to do is seal it up. If you seal it up, even if it's got a rubber seal, at some point in the future the rubber seal is going to deteriorate and the water is going to get in. So what you do is you build it with holes in the bottom to let it drain. You build it to let it drain with holes in the bottom, and you raise the PCB up. So the backing where it's fixed to the post in no way has anything to do with the internal PCB side of it. So to that end we keep the fixing holes. We need to make it wider for a start without actually. It's going to be black ABS, so tell you what we'll do. Well, we'll colour it after. We can't. These gland holes are no good because it needs to be able to take. Yeah, probably gonna have to start again. I'll tell you what we'll do. We'll start again. We'll start from nothing, I think. So what we want is let's start with a box. So, right, we're gonna start with a box. So I'm just gonna put it here like this, and that's it. I'm not gonna measure it, although I will make it a certain size. I'll make it 150 by 200. Okay, that's way too big, but we'll start with something. And we're going to give it a thickness. Okay, the thickness needs to be it needs to be robust to take a bit of a battering. Okay, but it needs to be able to screw down. So let's say 2mm, 3mm. Let's say 3mm. So 3mm thick. Just going to turn this radio off. Right, let's turn this radio off. Got a new radio handle today. Right. Let's get this sorted out. So we've got this flat surface, and we're going to have mounting holes. And ideally, it's going to fit onto a 100 by 100 post. So what we'll do is we'll straight away change that to 100 wide, and it can be oblong. So we've got 100 wide, and what have we got here? What did we say it was? 200. So we don't want 200, we'll say 150. So we'll bring it back 50 mil. Right, that's going to be our size. Now the post is already 100 wide, so you don't really want it sticking out. So we're going to come in 5 mil. And also in 5 mil. Right, and what's the size of this? 150 mil. That's okay, I think. Right, so we'll pretend it's okay. Now we want some sides to it, so we're going to go on the 3 mil bit. So we're going to do 3 mil. 3 mil, 3 mil, and 3 mil. Okay, so I'll just put one of those there, and we're going to bring the sides up. Now I need to raise this up actually, because we're going to present it. This box is going to be a presenter, as in it's going to push the PCB forward and push it in your face. Basically it's going to go, there you are. So it's going to look over the top. Hola, someone shouting hola.
Thank you very much and good luck. Bye-bye.
Right, so we've already got 3 mil, and we want it quite big. The sides, now do we need the sides big? It needs to be ergonomic. So we're going to have to do something very clever with the enclosure. Tell you what, I'm not going to raise the sides up yet. I'm going to put the PCB in. So we're going to get these are the right sizes. Thought it was. Yeah, these are the right sizes for the PCB. And what we want to do is we want to just copy them out. So we're going to have to make that a component, so we can paste in place. I need to bring them out over here, and we need to sort of line this up. So we're going to just drop it there for a minute. Let's bring it down to the surface. That's on the surface now. We need to... We know... Well... I need to grab that from the middle. I don't think I can. So what I'm going to have to do is I'm going to have to find the middle of this first. Alright, and then we're going to have to measure from here to there. 20.601. Yeah, so it's going to be difficult to work this out. Alright, it's probably better to measure it from there to the middle. Right, so we've got 42.54. 42, oh, I don't know how to do this. How do I make that in the middle? Well, I've got one way of doing it. I can join up. Let me just, I'll tell you what, I'll just join up. I'll join up the edges. And hopefully that's is okay. Yeah, it's going to allow me to grab hold of the whole thing. Now it's got a middle. The line there is going to confuse the hell out of it. Right, I need to get rid of the middle a minute. Yeah, get rid of the middle. I need to grab this by the middle. There it is. Problem is, I haven't grabbed it. Right, so I need to start again. I grab it by the middle and we need to go like that. And like that. And let's make sure it's going to grab it. Okay, I don't know if that's the middle or not. We'll find out. 4, 5, 6, 6, 9. No, it's not, is it? Not having much luck today. 2, 4, 3, 9, 9. No, it's not the middle. Right, so we need to grab the middle of this. And we need to find the middle of this. And we need to grab it again and find the middle of this. Now that's surely the middle. 24, 339. 399. Right, I'm not having good luck with this today. Don't know why. What is going on? And that's, they've stopped speaking. Let's go on to a different band. I'll turn it off. We'll turn it off. It's gone quiet now. Let's bring up something else. Let's have a look. Oh. I don't know. Where's there a noise? There's a noise there, but there's no noise there. Oh, there is. Yeah. So what's that? What's happened is somebody's transmitting a noise. So let's get rid of that out of there. Right, I've just deleted it out, so I'll leave it like that. Yeah, let's leave that running.
E63 Golf Juliet, contact Cardiff 125.855.
125.855, goodbye, E63 Golf Juliet.
Yeah, I don't think I can do that. I'm not sure if you're allowed to broadcast that, so I'll just leave that like that. I'll tell you what, we'll leave it on the call frequencies, why not? I'll tell you what we'll do, we'll put the other one back on and leave that on a call frequency as well. It's probably too late for anyone to be calling, really. Right, so we've got 3 call frequencies. Right, okay, we'll live with that. Well, we're monitoring 3 call frequencies. 10 FM, 2 meters, 2 meters FM call channel, and 70 centimeters call channel, and 10 FM. So the frequencies and the actual wavelength meterage don't correspond, so it's quite confusing to newcomers. Right, so why can't I get this to be any good? It's weird, isn't it? Why I can't get that to go? So the halfway mark is there. So that's why I'm not quite on it. So if I grab that from there and put it on there, then I do a halfway mark from down here, then grab this. Is that already the halfway mark? I think it is, so it's already on. Right, so yeah, let's get rid of that. The 3D printer's switched on. We don't want this anymore. Just need the holes in the right place. And we need to mount the whole thing up a bit on some pedestals. So it needs to be forced up. Let's check we got audio. On some pedestal. We got audio. So we've got our holes in the right place. We've got our background. We need now to bring some way to hold the PCB like this. So I need to probably, yeah, I need to grab some geometry. Go try to reuse all the calculations we've already done. So it worked okay. Apart from, right, so we've got everything now according to that, yeah. So if I grab that by the scruff of the neck, now if I grab it by that and oh, I'm in it, aren't I? Yeah. Right, if I copy it and paste it in place, but if I grab it by the center of this hole and then move it over to this hole, I'm in bang in the right place then. Right, so that's our PCB outline. It's got to sit inside there. Alright, that's good. So then we can do something like put a layer around it. What size layer? Yeah, I need a little bit of a lip in it. Say 1.5. Okay, that should be enough. Right, so then we've got that. So we've got all this. These aren't interacting with that, that's okay. We'll sort that out after. We've got an extra bit there for some reason. Right. We can get rid of some of this. Okay, so what do we want now? Bottom, yeah, we need to be able to take the lid off but leave the bottom so we can gland to it. And we've got to have some space in either side for the connector block. That's probably enough. What we need to do now is we need to bring the bottom up. So bring the bottom up. So we want the bottom, I'll say, we'll put a shroud around it like that. And this needs to be this bit. We're going to fit. Hang on, that's not going to work, is it? I'm not in the model. Now I'm in the model. Right. That needs to be a 20mm industry standard gland. So 20mm gland, and we need some clearance for the nut. Say we want it to be usable, so not really too worried about how big it is. So I mean, we could build the indent the nut into it, but I don't think we need to do that. So 20mm, let's just say 10mm. Let's say 10mm, so 40mm. So 40mm, that's our glanding plate. Okay. Let's come out a minute. Let's grab this, cut it, paste it in place. Right, it's part of the model now. Sort of. No, we seem to have lost something. Okay, so undo and undo, close, undo, open, undo, cut. So we'll leave it there for a minute. So what we can do is take the perimeter. I'm going to have to do some sides, I think, first. Let's do some sides. Right, so we've got our glanding plate. It's quite big, but it won't look that big once it's all on. Now we need to, we're going to bring that up high. So we need to develop a lip. It needs to have a lip. So we can't go right against the thing. So it needs to be almost flush. So what we want is a big enough lip. So we'll come it needs to go over that lip, so let's make that a lip. So if we do right, we're going to come this way, I think, this time. Right, and we're going to bring this up another 3mm. And what we want to do is we want to just make a line across the centre, across here. It's not doing it, why not? Oh, that's only a measure. Undo guide, undo guide. Right, I wanted to draw a line, not measure a line. Right, then I'm going to bring this out, also 3mm. So this is going to be, we hook the thing over the top. Right, so that's fine where that is. So our sides need to come over the top of this, and we need to raise this up. So we're going to raise these up to the 3mm as well. That means we can get rid of those extra lines there. Okay, so we've got that there, and we can hook over it, and we've got a bit of a lip, so yeah. And I've had an idea as well to get the water to not to try to come over. So what we need to do is make this in by 3mm, if we can do it. 3mm and 3mm. What I'm going to do, I'm going to put another line down here, down to there, and we're going to push the bottom in by 3mm. Yeah, that's what we're going to do. And this is so the water, if it wants to defy gravity and physics, it will do, because it'll flow around. But it's going to have a harder job of it. Now this is just the first layer of defense. So it's got a natural layer of defense. It also acts as a lip to hook the lid on. So we've got a 3mm overlap for the lip that hooks over it. We haven't done the cover yet, so the cover, it hooks over here. It doesn't hook over this. Comes flush to the back. And the same with this bit once it's hooked on, so we'll sort that out. Now, and we've got a flat bit which we also could do with a, do we need a, we'll have some drain holes. Do we need another lip on it? I don't think so. Let's have a look. So it's going to be that way up. So the water will drip. I should have done this the right way up, shouldn't I, really? Tell you what. Let's put it the way up, the right way up it's going to be. Alright, let's just put the whole thing the right way up. Otherwise we're going to be in a bit of a mess with it. Alright, that's the way up. Alright, that's going on a post. It's going on a metal post, 100mm wide post, or a wooden post. Plastic, I'm going to break a plastic enclosure for it. So it hooks on there. The top hooks on, hinges down. So I'm just thinking then, could it the whole thing slide over? No, we'll keep it like that in case there's something above it. You don't always get the room to slide things right over. So we'll keep it like that. Now is that lip big enough? 3mm lip, should be. Okay, so we've got our 3mm lip. We'll leave the bottom for a bit, like that. What we're going to do now, we want to raise, so at the minute we're sort of flat and we're stepped in the wrong direction if we want to do a 3D print, but there's no other way of doing it. You've got to have it that way. Yeah. Anyway, we'll build it. We'll see what we're going to do about support. Might be able to do it. Sometimes it can do it. Right. So we've got that bit. Now we want the whole thing. This bit here, we want forward now. So I'll tell you what we'll do. We'll. Right. So we probably might have cables coming through the back as well. Shouldn't have to do that though. Cable glands. Let's just put the cable glands in. I think 2 holes should do it. It's probably too much, but put 2 holes in. So I'll go half there. Can you go half again? You normally can. Not there, not today though. So that's 42, so 21. I'll go halfway down there. What's that like? It's not, oh, yeah, it's about right. So let's put a 20mm hole. So it needs to have a little bit more than 20mm bang on. We don't want to be struggling with it. So we'll go 10.5. 10.25. Right, and that'll give us 21mm. No, 20.5. Okay, we can live with that. Let's do one more. 10.25. The only trouble is the circle's not quite round, but I don't care. Right. And they're not part. It's not part of the thing yet, is it? No. So let's select these, cut them, and put them in here. Push it through. Right. So we've got our gland holes. Now they need to be able to be knocked out or drilled out. So what I didn't want to do is delete them. I shouldn't have done that. Undo, undo. So we want sort of. We need to, yeah. So we need to indent them. Say 1.5. 1.5, and we're going to indent that by, let's say 1mm. 1mm. Right, so we've got some indents. We need to copy these. I need to go up by 3mm, or was it 5mm? No, it's 3mm. So we're there, and we need to, yeah, do another step this side. 1.5. 1.5, and we need to pop that down. So we've got 3mm, so we need 1mm or 0.5mm. I don't know. So if we say 1mm, 1mm. So we've got altogether a 1mm bit in the middle that need to be drilled through. Tell you what, we'll go one step further. We'll go up another 0.25, 0.25, and from the top 0.25, 0.25. So what does that give us? Only a thin bit to drill through. A thin bit to drill through, and you can pop that out. Okay, that'll do. That's good enough. Right. Good enough for this one. Save it. Okay, so we've got our back now. We haven't got any way to mount it yet. And we've got some mounting stuff down here we've already done. Generally outside they don't do that arrangement. They just put a hole in it. So we'll copy the hole. I'll just measure it. So we've got 4.25 and 8. That'll do. Right. So we'll go into here. We're going to have to put some corner marks in it. Yeah, it's probably going to have 4 holes. So we just go like this. Come in 7.5. 7.5. 7.5 and 7.5, and we'll have some holes. 4.25 we said it was, so 2.125. Okay, so we've got our holes. Let's push them through. Oh, again, we don't want the holes. You need some holes, but they might not want the holes there. So you have to drill them, yeah. Okay, we'll keep it like that then. We'll keep that idea going. So we'll do the same again. 1.25. 1.5 on it. That's too much on them. So I'll say 1 mil. That's too much as well. Tell you what we'll do. We won't do that step. We'll just lower it through. So we'll come down by 1.25. 1.25. 1.25. 1.25, and we'll grab the holes again. I'll copy them. Copy them out. 3 mil. They should be on the back now, yeah. And we'll just go down 1.25, 1.25, 1.25, 0.25. Right, so we've got a similar thing going on, where if you want to drill them out or punch them out, you can. Alright, so they're where they're tight, sort of, as far as they can be with 3D printing, but we're not reliant on it because this is just the first layer of defense. So that's our fixings to the background, back post sorted, and our cable glands sorted. And what we want now is probably make this rounded event after. I'll keep it square for now. Right, so we want the PCB to be held off, floating in mid-air, not against anything. It needs to just float. So how do we make it float? Do we have a supports that stick up and a shroud? And if we do that, then we're containing, well, we'll have to, yeah. Right, let's try it. So at the minute we're still in there, so we need to grab all this apart from the holes. Or can we grab the lot? We'll try it. I think it'll lose the surface. No, we haven't lost the surface. We're okay this time. So we've got that there. So we need to bring this surface up. Needs to go up quite a lot. Say 15 mil, I'd say. 15 mil up. Okay. And now we're gonna need, these are the holes. That's the holes for the bit, but we need some support material, so we're gonna have to go. I suppose it'll go up to there. Hang on. Why does it do that, I wonder? So that is, let's go a bit less. I need to work out the size. So that's 4.65. And it needs to be 2 mil. Can we do 1.5 mil? That's not enough. We'd have to go all the way over, I think. Yeah. Tell you what we'll do. Yeah, let's just go as far as we can to the wall. Okay, we'll do that. I go as far as we can. Oh no, we don't do that. That's the wrong one. Right, didn't snap then, so I'm gonna have to just keep doing it until, well, it doesn't want to snap to it, don't know why. That's weird, isn't it? Why doesn't, what's going on here? One of these must be out, I think. Let's try this one. I think one of these is out. Yeah, they're both a bit out. Oh well. Go away. Go away. Right, so we've got them. So why aren't they the same? Oh, it must have them slightly out. Doesn't matter. Right. So we've got a lot to bring these up. Let's refer back to the working model. Right, so we've got to be flush. So that's 1.6. Yeah. So 1.6 down from the, yeah, the lip's got to be 1.6. So we could do with a line down 1.6. And bring this up to the line. Okay, up to the line. Yeah, that's okay. I haven't got a line that way. I can just do that and use that as a reference. So let's lose the lines. Okay, so we've got our inner bit raised up. So the water's got to get round the back, up and round the curves. It's got to get over this bit and it's got to get inside there. So I've had another idea. How about if I do that, and that, so it'll have a triple defense. Can I go down the other way? No, I can't. Oh, I can go wide by 1.5 mil. Right, then I can grab, hang on, then I can grab the sides and duplicate it down, duplicate it down, 1.5 mil, then join up the edges. Join up the edges. Oh, I haven't got a what's it there. Alright, so I need that, and the bottom. I need to copy it. .5 mil. Right, then I've got to join up. How do we join up? No, that's not enough. Thought that would have worked. Let's try it again. Normally works, that does. Right, has it worked this time? That worked there, and it worked there. Has it worked this side? Yeah. Okay, so we've got that, so we don't need now this. Okay, so we've got some extra bits we could do with getting rid of. Okay, what does it look like? We've got a few extra lines we don't want. I think. Yeah, we can get rid of, sure we can get rid of that now. Yeah, and that. Yeah. So now we've got just the section. Yeah, that's it. We've got no extra geometry. I don't think. No extra geometry, right, okay. So that's, we've got, right, so we've got the first layer of defense, this lip. We've got a second layer of defense by bringing it forward. Then we've got a third by having another lip on it. Any water gets past this into it, it's going to have to just drip round the sides and out the bottom. So we need to introduce some holes in the bottom, which we haven't done. Let's put some holes in the bottom. I'm glad I got around to it. I was thinking what to do tonight, and I just remembered I need a weatherproof external enclosure. It'd be nice to get this on the go. Right, get it 3D printed. So we want a couple of drain holes now. Definitely need drain holes, because it doesn't matter how good anything is, you're always going to have a problem needing some drain holes. We'll put 2 drain holes in. I'll put go to there and to there. Can I do it in the middle? No. Right. Yeah, so we're going to have a drain hole there. So let's come off there by, doesn't need to be much, 5mm. Let's do 5mm, and we'll have a small drain hole. How big is the drain hole? 3mm. Is that too much? 3. Yes, 3mm is too much. So we'll say 2.5. So we'll go 1.25. 1.25. Do we need a third hole? Yeah, let's have a third hole. Right. So we've got 3 drain holes. So we need to push them through 3mm. These are actually allowed to go through because these are drain holes. Always assume the water's going to get in. It might not get in for the first few years. So we've got built-in drain holes just in case. Right, and we also need drain holes here because we don't want to trap water. Imagine if it was somehow, it might be flood. There might be a flood. This might have been underwater for a while, and they might have turned the power off, and all this would seep in and fill up, and then when you switch it on, all the water hasn't drained away. So we want some more drain holes in here, in the bottom bit. So what we got there, 25. So let's just say, I don't know, 12. 12, and we'll do 5mm again. Right, I'll put some drain holes in here. Same size. Probably 3's too much, but it doesn't matter. Oh, I know what I've done. I haven't gone into the model. Now I have. So more drain holes. Okay, so we've got our 2 lots of 3 layers of protection and 2 lots of drain holes. Now you could indent that to get the water to flow in, but we'll leave it like that. Oh, I've lost my... Oh, what happened there? Alright, so what happened there? It's not 3mm, is it? What size is it? What was the wall thickness? Probably 2mm, wasn't it? 1.5, yeah. 1.5, that's enough really. 1.5 is enough. So I'll just push these through. 1.5. Okay, so now we should have, yeah, holes, that's it. Okay, so we've taken care of the glanding holes, taking care of the drain holes. What's next? Alright, our PCB can sit on. Why does that one look weird? No, it isn't, it's okay. So let's get a PCB next. Where's the PCB? Didn't we get a PCB? That's not the PCB, that is. That's right. So we want that up here on its side. Just like that. And we want to grab that from a hole. Let's grab it from a hole if we can. Yeah, we didn't copy it, but it doesn't matter, we're going to get rid of that anyway. So put this over here. It's going to be awkward. Is there a way, can I... Alright, so there we have it. It's flush with that, so it needs to come this way. 1.6mm. Okay. So that should all be lined up now with a bit of luck. Yeah, over top of the hole. So all the fixings line up, that's fine. It's only a representation. It's too far over for some reason. But yeah, it's too far over. Maybe that one hole was out. Yeah, it's only a representation. Let's bring it over 0.25. And a little bit more. 0.1. Right, what's that like? That's alright. Yeah. So you got your PCB there. Okay. So we've got our knockout fixing holes or drill out. And we've got a smooth area here. I know some people have, well, they're injection molded, you see. These aren't injection molded. So the injection molded, they have ribs on, so they can use less plastic. The 3D printing, it works in a slightly different way. It does lattice infill, whereas injection mold is a solid piece, so they have to exoskeleton to save the plastic, where it's internal on this stuff. So we'll ignore norms for injection molding. We're not interested in injection molding, although It'd be nice to. You can do it at home. You have to melt your pellets through a screw. It's quite complicated, but it is possible. Right, so we've got room for our fixings down here. We've got room for our terminals. These aren't the right ones, they're plug-in and they stick down a bit. Cables can come in and you can gland them. So they've got knockouts there, drain holes. Let's have a look, is there anything else? Anything else? So if the water gets in here, it'll get onto there, then it'll drip round. There's no way it can get to this point because the hood is shaped so gravity will not allow it. You've got drain holes, so it should never be able to fill up. If it gets if there's a big flood and it fills this up, they normally turn it off if there's a flood, and then when it drains, the flood subsides, the water will drain out, and by the time they switch it on, maybe it's dried off with a bit of luck. You never know. Right, so that is the yeah, so that could be it. Now if you've got an OLED, you could do with a cover over top of this to hold it in, so an inner cover to hold the OLED in, rather than just have the bare PCB. So to that end, you could have a cover. Right, so we could pretend we've got the cover still. It would be nice if we could just use a standard cover. Alright, let's have the top back. So the top is not a standard cover. Yeah, it'd be nice because it'll hold everything in and hold the OLED in if you want an OLED and different things. Yeah. So what we want now is a cover to fit over that. So we'll go back. Let's open another instance. Bring in a cover, a standard cover that fits on a non-standard base. Right, where is it? Okay, so standard cover is one of these. There's your standard cover. Copy that. Oh, while we're at it, we might as well have the button as well. Okay. And I suppose while we were at it, we could have just put a DIN rail in and put the whole thing in on a DIN rail and mounted it, and it's already got the fixings and everything in place. That's an idea, isn't it? But now we'll be printing more plastics when the back is the new base. Now we'll leave that idea because we're trying to keep the time it takes, but it would be something we've already made anyway. So we'll paste. Right, so we need to bring that around upright like that. Need to grab it by the horns. Grab it by this one here and put the whole thing over here. That's not easy. Hang on. easy. Right, this is not going to be easy, is it? It's not. Right, so it's not sort of. Maybe that's it. Right, so we've got our cover. Oh yeah, it looks lined up. That was lucky. Okay, so we've got our standard cover on. Now it looks like it's because it's designed to go through. So we've probably got to set this back a tiny bit. Yeah, because there'll be an overlap. Yeah, there's your overlap. Because that sits in like that. We're trying to use a standard cover. We don't have to use a standard cover, but it'd be nice to use a standard cover. It's already been tried and tested. Yeah. We'll use a standard cover. So now we've got to modify the back. Okay, fair enough. Let's just save that. Perhaps we should have used a standard cover in the first place. Yeah, should have modified a standard one. Right, can I just hide the top? Yeah. And the PCB. And the PCB. Right. Oh. Push button rod. Right. So we want to this lip, we want the lip, but we don't want it there. We want the lip away. So how are we going to do that? We're going to have to put back that. Select all these bits again. And we're going to have to copy it, whatever the width was, 1.5 mil. So we've got, yeah, our lip back. So what we're going to have to do is we'll pull that back by, say, I don't know, 3 mil, and push the top back by 3 mil. So we've pushed that rim back a bit. That's just to stop the water flowing over. Okay, so then we put our enclosure top back on. And we've got to modify the rim to match the lid somehow. Yeah, so it's got to come back a touch. That's weird, because I thought it was the same as a PCB. Or am I... Oh, let's put the PCB back. So you've got your PCB. Can't actually see what's going on there, so that's not touching the PCB, is it? It's difficult to see in different colours. Right. What's different? So I go over to this one. That's what it's based on. Which one? It's like that one, isn't it? So if I get that one, just bring that around like that. Bring that up here. Right, so let's have a look at the design. Oh, you've got this ridge going on here, so so really that ought to be right. How are we going to do this? So we really ought to put that one. Yeah, we're going to have to get rid of that and put this one in its place. That's okay. It's alright, I had the idea after I'd already done this bit. Right, let's do that then. Let's tidy this up. Can always put the rim back on after. Right, so we're gonna get rid of all this. At least we can do it easy by just doing that. Okay, so it's gone. It's alright. Right, so now this, we know the lid's in the right place, so it'll be very easy to push this lid in line with this here. Right, that's the lid in the right place. So all we need to do now is extend it off there, make that lid part of the back. So we're going to now just make sure we're lined up. Yeah, we are. So we're going to lose the top and the PCB, and we need to incorporate that into the back. And we already know this is okay, but while we're incorporating it, we need the lip, the secondary lip on. We don't need the holes, so let's get rid of the holes. Let's get rid of these. Alright, so we've got rid of the holes. We need to extend the back down a bit, so we need to see it that way on. Find out how far away it is from the back. Just measure 4.8 mil. Yeah, 4.8 mil. So we need to extend the back by 4.8 mil. Here we go. So let's just do that. Oh, go into there and move that by 4.8 mil. Okay. Right, so we should be touching the back now. Yeah. So we're part of the back, and okay, we can do it that way and have an extra bit of thickness here if we want. Give it some strength, why not? So we've got that, and we need a lip on it now. So we need to put a lip on it. So are we in it? No. Right, so what we need to do, we can just put a lip on it before we do anything. So about there. Start from there, and we'll do a 1.5 lip. And we gotta go all the way around. Oh, right, hang on then. What size is that? Halfway, 6.9. Oh, we did it from there, so let's do it again. 1.5. Right, round the back. Okay. So we need to get rid of this bit here. How do we get rid of that? So we go like that. Tell you what, we'll leave that there. We'll just do it like this. Yeah, I'll just add it to this. Right, fiddly stuff, innit? Fiddly stuff, right. Got to do the lid yet. Got to do the lid. Okay, that's that. So get rid of all this stuff. All the construction lines. Okay. Right, so we've got that there. We need to go up. So we need to get rid of that. That was a bad idea, wasn't it? Right, so we need to go. Can we go up 1.5? Okay, so we're getting a ridge. We can sort out the weirdness in a minute. Oh dear, it's a bit laborious. I'll sort that out in a minute. We want this lip. Do we need the lip at the bottom? Yeah, might as well. Might as well. Okay, so I need to get rid of the extra bit now. The extra geometry. Oh my god, what am I doing? What did John Lennon say? War is over if you want it to be. God. War is over. Right, is that it? No? Can't be, there's always one more missing somewhere. Yeah, there it is. The people have the power, they just don't know it. War is over if you want it to be. Is that it? Is that it? Are there any more? Are there any more? No, I don't think there are. Okay. Right. Fair play. Oh, there's some extra geometry. Is that extra geometry in there? Is it? Yeah, it is, isn't it? Yeah, we don't need that. Do we? No, we don't need that. Let's take it away. What have we done? I don't know if we've lost it. Yeah, we've lost some. War is over if you want it. Right, so we need to fill those out, I think. Oh my god, it's never ending. Never ending. Wouldn't be so bad if I sold some stuff. Never sold anything. Sold 2. Yeah. Crap. Can't sell it. If it's a PCB, they don't know what to do with it. Needs to be in a pretty box. A waterproof box. Is that it? Oh god, don't go inside it. Right, is that it? No. That's not it. Is that it? Certainly looks like it, is it? Is it it? My hand's getting tired now with all this scrolling around. Scrolling around. War is over if you want it to be. People have the power, they just don't know it. Well, the person had the power in his hand, he shot him. He knew it. Right, so is that it? Are there any more? No. Oh, right, we've got another layer of whatever, that's it. Right, so what we want now, we want to get rid of the excess, or is it gone? Yeah, it's still there. Can we get rid of the excess? That doesn't look good. No. Okay. I don't know. Do we leave it there? Why won't it let it? Why? Oh, hang on. I don't know. Right. What have we lost anything? No, because it needs to be there, doesn't it? Yeah, that's right. Maybe not all of it, but some of it. I don't know. We'll leave it. Right. We'll leave it there. Okay, so we've got the enclosure, we've got our lip, and it should just fit. Now, what it isn't part of that yet. So it needs to be part of that. It'll be interesting to see if it can even print all this in one go, but it's got to. Let's get the right way up for a start. We don't need this anymore. Okay. Right, so we need to make that. We need to explode that. Or we just grab it, cut it and paste it in place. And now it's all part of the plan. Yeah. That'll be interesting to see if it'll work. Right, so I need to intersect the faces with the model. Alright. We need to colour it all black plastic. Let's do a lot of colouring now then. What colour do we go? Synthetic? Should we do synthetic? How about that? Is that okay? I suppose it's as good as any. I am not a number, I am a free man. I am not a free man, I am a number. What's that doing there like that? I am not a number, I am a free man. That showed so much promise, that series. It all went, they let him have rights, they let him have, what do you call it? Creative rights, and it all went downhill. Yeah, let him create, and it went to, as they call it, Scheißen. We would let you have creative rights, but then we want to have a job later, and don't think we'll have a job if we let you have creative rights. Right, so we're getting there. Right, I'm sick and tired of being sick and tired. I'm sick and tired of being sick and tired of being sick and tired. I'm sick and tired of being sick and tired. I'm sick and tired of being sick and tired. Right, am I done now? No. There's always more hiding. You're hiding. Why is that blue there? It's inside, isn't it? I don't care. I don't give a damn. I just don't care. Oh my god, there's more. More and more and more and more and more. More and more and more and more. Oh god, there's some hiding. Hiding away. More hiding away. Bloody hell, imagine if you're doing this all day, you'd have no thumb and finger left. Right, is that it? No, there's more. I still see blue. I can see blue. Right, okay, whatever it is. Right, is that it? No, there's more there, look. And there. Is that it? Is that it? Are there any more? Are there any more? No, I think that's it. So after all that, wait, we still haven't got a lid. But the lid is not printed. Ah, we've got a bit of a problem here. What's that? Pop. Oh, the radio's still on. Might as well turn these off. It's just a waste of power. Turn them radios off. Turn it off. 74 drop frames. 0.09% of drop frames. You've got to expect a few on a Friday night, haven't you? Right. So this could be started to be printed, couldn't it? Let's have a look. So we put on the top the PCB and the lid, the push rod and the button top. We don't need this one anymore. Oh, what's that? Why is that? Why have we got a line there? That's weird, isn't it? Oh, it's the relay. Oh, that's spoilt it. My PCB is not down enough, is it? That's why. Alright, let's get rid of that. My PCB and cover is not down enough. No. The cover is. The PCB isn't. So, yeah, you can see the PCB is sticking up, look. So, that begs the question, why is it sticking up? How far is it sticking up? You can't tell. I cannot tell. Oh, it's a fair way, isn't it? It's sticking up about 2.1, is it? .1. Is it now sticking up? Oh, I think that's alright. Right, okay. Let's try it now. Right, what's it look like now? Is it in? It is in. Will the lid fit on? No. Yes. Okay. So we've got a mount. We've got a landing plate, and we've got a cover for the inner bit. Well, what we haven't got is a way to mount. We need something to screw our lid down to that. So I can't even print that bit out yet. So what, before we go much further, let's open up Bamboo Studio. See if we can slice it. 1 o'clock in the morning. Oh, 12 o'clock, sorry. I don't think I'll be printing anything tonight, will I? Nah, probably not. I might have to go on to 2 episodes this. 1 hour 43, we'll go for another 15 minutes. Right, so we'll get that. We'll just try that and see. Let's smooth it. Export. See if we can. See if it'll slice. 3D printed models. Right, it's going to be called waterproof. STL, that's it. Oh, it's the base. Not base, the back. The back and the front is all it's going to be on this one, the back and the front. Right, let's bring over Bamboo Studio, file new, import, STL. Right. Okay. Where is it? I forgot what I called it now. That's not it, is it? No. None of them. Oh dear. Right. I forgot what I called it. It must be getting late. Weatherproof STL. There it is. Oh, 20 non-manifold edges. And it seems to have put it upright. Now that's the way I designed it. So, let's see what it says about orientation. It's left it where it was. Auto orientate. Well, maybe it wants me to repair it first. So it's repaired it and orientate. Ah, it's repaired it and it's put it on its back. Okay. Now I can't make that yet because I've got no way to screw the front down. Needs to have some scrub screw bases and make the front. So it's a shame I can't print that out. Oh, I've just moved it. Right, so, but it hasn't complained. Let's try slicing it. Right, it says it was okay and it didn't need any Didn't need any support material, that's good. £1.15, an hour and 49 minutes. As it stands. Yeah, okay. Right, it's in good nick. Right. Anyway, so unfortunately, I think that would work. I'm not going to print it out, so we need to design some. We need to design for the front cover. I don't want to rush it. So in that case, we'll leave it at that for tonight. At least we've started it. Yeah, leave it at that for tonight. Okay, well that's a quick one. So that's the weatherproof enclosure for the UPAS KP V2 and the UPAS project 14 in the series. Alright then. Well, thanks for watching and catch you again. Bye bye.
This constitutes all available data. That information is not available